Well, good morning, everybody. I want to start off again today by looking at some satellite data. There was a lot of just quite fascinating things going on our geostationary satellite imagery yesterday. I mean, from the convection that was born along the sea breeze that kind of lined the Carolina coast down to Florida, throughout this whole area, just watch these storms blow up in the afternoon heat, feeding on the convergence of the sea breeze. This is always a fascinating thing here. You know, we're delivering rains to some key places here that have been quite dry. To the deeper lows that were moving north of the Great Lakes, the one that was moving here in the northern plains, and then the storms that kind of erupted along the Dryline, which set right in through this area last night. Now, I've got to spend the last 3 days with a group from New Mexico, Texas, and Oklahoma. This is kind of our South Plains division. They were in town. We're doing some workshops and getting a chance to talk. And it was interesting to watch this because many of the people I've been with live here. And so they were getting reports and pictures about the monstrous hail and the tornadoes from some of these powerful supercells. Now, the feature on which they formed is this thing called the Dryline. I know that some of you watching this are professional meteorologists, and you know this in and out. I know I've got folks on here that, of course, live in this area and are quite familiar with it. But if you've never experienced kind of what the Dryline is, or even heard how it's explained, I'm just going to tell you something. There's a reason why the most violent storms on Earth are here. And it has something to do with the clash of extremely dry air coming out of the desert Southwest and off the Rocky Mountains and out of the Mojave Desert and Mexico here, and colliding with extremely moist air that's loaded with potential energy because of the water vapor in it. And it just blows up into some of the largest storms on Earth. Now, it's not to say that other places on Earth don't have big storms. I mean, just go down to South America right now. If I had to pick a second place, I'd have to say it's southern Brazil into Argentina. That's just me, my opinion on where we get storms similar size to this. But take a look at this, okay? Now, if you're not interested in this explanation, just zip forward. There's more content in a few minutes. But I'm going to show you a zoomed in view of this. Now, you'll watch, there's a boundary right here. Can you see this? On which you're going to see storms pop. It comes all the way down here to this part of Texas. And that boundary where that cumulus cloud field sits is one of the features we can use to kind of demarcate where the extremely humid air is versus where the extremely dry air is. And this is a very similar situation as to what we talked about yesterday. These discrete cells popping up on this boundary. Notice how their anvils are getting blown off in this direction, so off to the east and northeast. The boundary sits here, which means we have the wind shear vector crossing the boundary. And what's important about that is that allows the storms to continue to be discrete. Now, the storms that were over in this part of Texas, of which dropped a tremendous amount of rain, I'll show you that in a few moments. This is setting up entirely different. There's actually another stalled out frontal boundary that's sitting right in through this area. But I want to focus on the dry line. Now, here's how this works, okay? I know this is not going to seem intuitive because we often think about really hot, humid days as the atmosphere feeling, heavy to us, right? And one of the reasons it does is because our bodies try to cool by sweating. So if your body is not allowed to sweat because the environment into which you're sweating is already near saturation, in other words, it's a humid environment, it's not efficient. You don't cool off, and it feels like the atmosphere is quite weighty. But in reality, the mass of the atmosphere, and therefore its density, is actually lower on the humid side of this air mass versus the dry. And the reason for that kind of boils down to some chemistry. And that chemistry is dry air, mostly nitrogen and oxygen, has a molecular mass of about 29 grams per mole. If you were to replace some of that with water vapor, which has a molecular mass of 18 grams per mole, you're essentially reducing the total mass. And as a result, when these two air masses collide, the one that kind of stays closer to the ground and undercuts is the dry air. It's the more dense air mass. So when the humid air mass hits it, it pops and goes up in the atmosphere and realizes that potential energy stored in the water vapor. Now, why is water vapor storing potential energy? It's storing it in the fact that we're converting vapor into liquid, and that releases the heat, right? So in a sense, these are producing their own heat by which they explode into the atmosphere. And we need really cold upper atmospheres to make these storms pop because the storm cell itself is hot. Here's another neat thing. When you walk underneath one of these thunderstorms, you would think with all that weight of all that mass in the water that's above you, because there's a lot. I mean, we're talking some of these storms weigh not just tons, but thousands of tons, all right? The actual air pressure underneath them is lower. simply due to the heating. It's a fascinating thing to study. But that dry line, and you can actually see how the thunderstorms are influencing the position of the dry line throughout the day, can better be seen by looking at this. So West Texas has a mesonet, and we're looking at the station data for temperatures. Now, to take note of this, as you go across this part of Texas, let's just go from here to here. It goes from the 80s to the upper 80s, low 90s, right? And a lot of this is due to sunshine throughout the day and who got it and who didn't. So there's some cooler air a bit farther to the north. And if you kind of come back here and take note of this throughout the day, there's more cloud cover there. All right, now, as we take a look at these temperatures, the temperature difference is not driving the density difference, because this would be the more dense air mass based on temperature, right? Because it's colder. What's driving the difference is seen right here. This is a look at the dew point temperatures. So dew point's a measure of moisture. It's an absolute measure of moisture. So as you look over here, we had dew points in the 70s and then the upper 60s come right across this line that sat right here. I mean, look at these two stations, 39 to 65. Right in through there is the position of that dry line. Maybe it's easier to see if we look at relative humidity. Now remember, humidity is relative to temperature. So when you look at this, these very, very low relative humidities, well, the higher we crank the temperature, if we don't change the moisture, the lower these numbers get. But this is what that dry line feature looks like. And again, the clash of these two air masses, the less dense one is the hot, humid one, not the hot, dry. So this is where the air pops, and that's where the thunderstorms were. So we could actually see this using the Amarillo radar. This right here is a bit of clear air echo, and a lot of what's being seen here is you can actually get echo off of turbulence in the atmosphere. You can get it off of dust and bugs and all sorts of things, and it was sitting right along that dry line. So notice the storms popped here. What's also neat about this is you can even see where the wind turbines were. These were all echoes from wind turbines. And I was sitting with a guy yesterday who's right here. He lives right in this area. And as we were looking at the radar, I said, well, what you've got here is some of the pinks and the deep reds. This is where this storm at this moment was producing some hail. This polygon means that the National Weather Service has issued a tornado warning for this area. And the big reason for that is here's the hook echo that's on the back side of this. And that's because the storm is rotating. And how we know it's rotating? Well, if you're there visibly watching it, you can see the rotation. There's never a question. If you see a thunderstorm and you're like, I'm not sure if that's rotating, it's not, okay? But if you see it, and you'll know when they're spinning. And if you take a look very closely here, see this red and the green? This is a radial velocity image. And so what you've got here is everywhere that you see the red, that is where the atmosphere is blowing precipitation particles away from the radar. And the radar is right there. So the red means on this side of the storm, you have flow going in this direction. And the green means that direction, toward the radar. So essentially, you can see the rotation where the red meets the green. We call that a velocity couplet. So to complete this story, we of course know that there was tornadoes there. We saw tons of pictures, and this one was sent to me. So that's why I have permission to show it to you. I just want to let you know I don't show other Twitter followers, their content without their permission, or if we don't purchase their stuff. So this was given to me so I can show it to you, but that's the tornado that was inside of that couplet right here. And had it been night and we couldn't see that tornado, we would rely on the radar to give us what we call a Doppler indicated tornado, which is when we find these couplets. And the National Weather Service warns every single one of those couplets they find inside these thunderstorms, and that's how they do their job, and they're amazing at it. Our National Weather Service, in my opinion, is top notch. All right, I just wanted to share that with you because I find this stuff quite fascinating. These storms also produce a lot of hail, and there's been no shortage, I think, that you've seen of pictures and videos of what some of the hail looked like. Some of it was very large. We saw hailstones bigger than grapefruit out of these storms, so I just want to give you this kind of blown out view from the last 24 hours here in the U.S., but if we kind of zoom in down here in the southern plains, a few of these storms, they were capable, making large hail. So I went to the Storm Prediction Center's website. We had 134 reports of severe weather, and you can kind of hone in here, 16 reports of tornadoes. And by the way, I want to let you know, the tornado that went yesterday through parts of Oklahoma, that was a monstrous tornado. There's a lot of controversy over it right now because the damage indicators we used to use the F scale or the EF scale, the new one we have that we came out with, 2010? If the tornado doesn't hit anything, that scale is difficult to use. So despite the fact that the radar measured massive gate-to-gate velocities, it will probably go down in the records as a weaker tornado because it didn't hit anything substantial. Okay, sorry about all that, but I wanted to be clear on a couple of things. So again, spc.noaa.gov, great website. And I want to make sure that you see we do have marginal risks on Friday and Saturday, but it's next Monday we're going to have to talk about here in a few moments. Okay, let's take a look at some radar data. So let's kind of pick back up with getting this forecast going. Here is just a look at the recent precipitation, more through Nebraska, more through parts of Kansas. Did it fill in the holes fully? Not yet, but we had moisture in that area. Parts of Iowa picked up on some precipitation as well. And we had, of course, some isolated storms that hit throughout the southeast, some moisture moving through the New England area. And you can see on the backside of this, a lot of this morning in Montana, snow. We got our next week low coming in here to Washington and Oregon right now as we talk as well. So how about the last 24 hours of total accumulated precipitation? Just kind of take a look at those areas. And now you can start to see where we see the very, very heavy rainfall that came out of that other storm that was over here in this part of eastern Texas. So there's your isolated convection along the coast. You can see what was running through the Canadian kind of prairie into the Great Lakes as well. And then, of course, our current storm system. All right, so where do we land this morning? Well, there's going to be an episode of some pretty cold air that's moving into the northwest. We're actually going to be talking more about snow in the Sierra Nevada and the Rockies and the Cascades as well. But this morning, that snow's right in through here. Freeze warnings again on this side of the Snake River Valley and also in parts of the Columbia Basin. And as we come down south, there's flood watches out for a large area of Texas along the Red River as well. Stronger winds on the backside, and this is all fog. As we look at what might happen later today, I'm going to show you using the new European model, the HRES, not the artificial intelligence. This is the high-resolution version. This is where we're looking at humidities tonight at 7 p.m. So this is what my new maps will look like. And I set a goal. You will get the whole new version of my website by the end of this month. That's my target. I hope I can get there for you. But what you see here is that by tonight, instead of the dry line being way over here, we can kind of follow the contours of the humidity. And it's meandering and moving. It's complicated and beautiful thing. So it's going to be farther east in Texas. And just take note that because of that position of where the humid air is versus the dry, that's where the risk of the severe storms will be. All right. Okay, from there, I mentioned snow in Montana, so I pulled up the surface obs. And right through these surface observations, see that 3-star right there? That is a heavy snow that's currently falling in this part of Montana. So we dipped down toward freezing this morning, and it is snowing pretty well there. And the models picked up on that as well. So let's kind of take this forward with a high-res NAM. So this is this morning playing into this afternoon and this evening. And again, you can see where we're expecting the storms possibly showing up here in the late afternoon and evening hours. Overall, broad area precipitation moves through Missouri toward Illinois. There's wet weather in the upper Midwest, more snow showers for parts of Montana, and there's snow that's moving through Oregon into Idaho as well, and quite cold air with that. So as we get into Friday, this is early Friday morning. The front passes through parts of the eastern Corn Belt. It stretches clear down here to parts of eastern Texas, Louisiana, which have been extremely wet as of late. And then we're going to watch on Friday night another frontal boundary show up here around the south side of this low that's going to sneak through Minnesota, getting into parts of South Dakota, Nebraska, maybe stretching back even to Colorado. And that frontal boundary is one I'm going to be watching carefully for the chances of rain coming back into that large hole that's been missed in parts of Kansas. So this is now once we get into Saturday. Now scattered precip through the east, but the attention is going to go back here. This is the much deeper low that we're going to be concerned about come Monday, ejecting right here into the middle part of the United States. So through Saturday morning into Saturday midday, take a look at how cold the air is in this. Snow in the Sierra Nevada, snow in the Cascades, snow at higher elevation in Oregon. And this is just going to tell us that there's enough cold air that this trough is going to punch pretty far to the south before it ejects. And it's right here, right now. That's the one we're watching. So here's the one that's exiting. This is the one that's going to be entering the United States. So to show it to you, let's go to the European ensemble. It's this guy right here. So as that one digs, this is where it ends up by Sunday. And as it digs through California, Oregon, Nevada, it comes out on Monday and just sweeps through. I mean, this is a classic look of a severe weather setup in this part of the plains. So we're going to watch that area most carefully on the leading edge of that trough. Now after that, that trough sweeps through and deepens, and it's sitting here through about May 8th. This is the risk of the colder air anchored in this trough for a while. Now, we'll talk about how cold in just a few moments, but what I notice is that by the 9th, 10th, and 11th, now you know that we've been watching that time frame for colder air to move through this part of the country. And the European ensemble by the 13th is dropping the coolest air in the Great Lakes. And I've been watching for the frost risk there. But there is something that's starting to shift around the 13th. And that is, I no longer see the models producing deep troughs of low pressure that come in and dive, which means we're going to get a bit of a change in the pattern, but it's still another 7 to 10 days away, maybe even longer than that, for us to kind of realize this change. So given all of that, let me just take you out there to the Storm Prediction Center's risk area on Monday night, and that's when they expect that trough to be coming through. So there's that region we're going to watch all weekend long for the evolution of what the severe weather threat's going to be here. All right, let's do our 5-model rundown. Now, there's something about this that has really got me excited. I mean, just looking forward to, and that is the precipitation coming throughout the Canadian Prairie. Now, in the northern plains, in this part of Nebraska and Iowa, Missouri, there are places here that need a break. We got to turn things off a bit to get a crop fully established. And really, really wet conditions down here in Texas, parts of Arkansas, Louisiana. This is also a positive. We've got to see moisture return back into this region. So let's see if the other models agree with this. And by the way, that's not to leave out the really wet conditions coming through here. So this is the artificial intelligence. This would be the national blend of models. Again, I see a lot of consistency here. This is the WPC. Here is the European. Look at that. Models have missed this so many times. There's a big question mark here. And then this is the, that's way too far out. That's a 14-day forecast. Let me dial that back for you. That's a 7-day forecast from the GFS. Now note the differences between the GFS and the European, especially in Texas. The GFS is extremely wet here. The European is much wetter farther to the south. The Delta is looking quite wet as well. And so there's a lot of differences here in where the models are putting down their heaviest precipitation, but they're all making rain, as you saw. Probability-wise, this is the best chance of getting over an inch. That's a large area with over an inch of precipitation through May 12th. And if we step this up to 2 inches, again, high probabilities of extremely wet conditions down here. But take note of the additional chances of getting a lot of moisture here in this part of the northern plains into the Canadian Prairie. And also take note of what's coming through the Pacific Northwest. If we go looking for who's dry, we just got the new model run literally just snuck in there. This is what I've got for the next 10 days. So we've continued to peel back the risk of dry conditions here, but there will be question marks as to this particular area and how much moisture it's going to be able to get out of this pattern. So there you go. Let's get into one important thing to compare that against, and that is the last 14 days. So new mapping style here just to kind of give us more shading of colors into these high precipitation amounts. So where we just saw the heaviest rainfalls, the last 2 weeks we've had 2, 3, 4 times normal precipitation. And question marks remain here as to how we can return moisture into this area. And by the way, this is through May 1st. So I don't have yesterday's storms because it was through 7 a.m. on May 1st. That's why you don't see these here. Will we be able to return moisture to this part of the Mid-Atlantic back to Virginia and North Carolina? Those are all kind of big questions I want to see answered in this forecast. All right, let's do a little model comparison here. We're going to start off with the GFS on the left, the European on the right. So we've already discussed this storm system and the one that follows it. Pretty good timing overall, I think, in the models on the position of that front. Here's the deep low Saturday morning, getting into Saturday afternoon and evening into Sunday morning. Look at that sneaking in there into Oregon and California. That's a snowmaker in the mountains in the west. I'll show you how much in just a few minutes. And then it's going to be on Monday afternoon and evening when this erupts. And right in through this corridor is where we're going to keep our closest eye on the severe weather. This will deliver, because of the speed and position and where that low goes, better chances of that wraparound region hitting Montana. And we've talked about lately, how many times this area has been missed. So to see this is impressive for precipitation in that region. So the low by next Tuesday night is now moving toward the Mississippi River, the front is. And then what we'll need to watch is the chance for that low to leave a lingering boundary here. Can you kind of see it in both models? And what I'll want to know is, as we get out there past the 8th and the 9th and the 10th, is it one of those scenarios where we leave this lingering boundary on which we could start to see repeated chances of very heavy rain kind of tucked away in this area? And also take note that even though this is all the way out there to next Friday, the models are trying to put down even more snow in the Colorado Rockies. So looking at all of that kind of in composite, I just want to show you that the 9th through the 13th, the CPC is also kind of thinking of this same idea of that lingering frontal boundary on which we're going to feed plenty of Gulf moisture, but the potential for the risk of heavier precipitation in this area. From there, though, I did mention snow, so we better go have a look at it. This is the European model from this morning looking at total accumulated snow. And as we watch this system this weekend come in through the west, we'll just stretch this out to 1 week. We've got potential here picking up 10 to 15 inches at the highest elevations here in the Rockies. Take a look at the Sierra Nevada. I mean, the models right now are going after these colors, and the Cascades getting a late dose of snow out of this too. In week 2, this is what the pattern's looking like. So you can start to see that area. Again, what time frame were we looking at again? Yeah, the 9th through the 13th, sorry. That seems to be this time period over which some of the models are picking up on that lingering boundary. But what I'll be curious to see is, does this area actually get a drier look into week 2, meaning that we start to plant? How about the southeast as well? All questions to be answered. But I do think the pattern begins to change. We talked about it a lot yesterday. Okay, temperature-wise, frost risk over the next 7 days. Take a close look at this map and let's talk about where these temperatures are going to go. Max temperatures today on Thursday, much cooler across the northern plains getting into Friday as well and Saturday. The next deep low is now coming into the west, so this is the one that's going to be producing the snow over the weekend. High temperatures here are looking like 10 to 15 degrees cooler than average. Montana, you're back on your wild ride again, back up in the 80s by Sunday. Here's Monday into Tuesday, back to the 50s, so 30-degree swing in 2 days here in Montana. But as we get up there further, this would be about the time frame that frontal boundary begins to stall in this area. And you'll notice that to the south of it, they are projecting the risk of hazardous temperatures, which this time of year are getting into those mid-90 numbers. But day 5 through 10 looks a bit something like this, according to the GFS, anchoring the coldest air here. This is about that time frame where I'm going to say, is there a boundary that lingers in this area on which we get some heavy rains? But day 10 through 15, that cooler air starts to move. And this is the pattern shift mid-month we have to keep an eye on. It's a drier shift. It's a warmer shift in the west. And I always questioned the risk of the cooler air coming into the Great Lakes states across the northern tier of the U.S. into the northeast. Now, the European model, day 5 through 10, follows the GFS, or they both mimic one another, with bringing that cooler air into the midsection of the country. But we've been questioning this time period, and the artificial intelligence model seems to have a better handle on kind of finding these features. But the coldest morning I could find out there would be Tuesday, May 14th. And if you just take the forecast at its word here, it has a frost in the UP, but not predicting one. We'll get down into the, let me shrink that up. We'll get down here so you can see the color bar. We'll get down into the possibly the mid-upper 30s in this area, but I still don't have evidence of an unseasonal, very late frost in that region. So let's wrap this up with the last couple of things here. I noticed that in the month of April, if we look back at the sea level pressure anomalies, we had much higher than average pressure sitting here. And we know that because of that, we watch storm systems basically do this and then deepen as they move toward the Canadian prairie. So blue is lower than average pressure. The warmer colors represent higher than average pressure. Now, the reason why I bring that up is I keep mentioning this mid-May shift. And the models are doing this. If you look at May 7 to June 7, where that ridge was, which was here, the high pressure cell was kind of sitting in this area, they're now forecasting its net mean position here, taking the low that was there and kind of pushing it a little bit farther. So can you see how there's a bit of a progression in this pattern? And what that could possibly do, as we've been discussing, is reshape the way the flow is coming into the west and exiting east and splitting. And remember, that northwest flow could open up some drier conditions here. So watch what the precipitation pattern does during that time frame. Again, this would be May 7 to June 7. We start to see drier time periods opening, I think, past mid-month here. Could we keep part of the Mid-South a bit wet? I think this is largely due to the wetter conditions we forecast from the 9th through the 13th. And could the Northeast actually get some decent moisture, which they probably need? We just don't want excessive moisture coming in. But I think this could be the resultant pattern out of that small shift in the pressure, which we just analyzed. From there, I do want to let you know that the MJO, which had been projected to sweep, is now collapsed again, meaning that that's taken away from our kind of forecast arsenal, which is why we're still kind of reformulating some ideas about what the rest of May into June is going to be. I still have to live it week at a time here and watch this pattern change, but you now know my latest thoughts. So let's just blow this out to a quick international look. As we stretch this out over the next 10 days, looking at the European model global temperature anomalies, this is 10 days put together, quite cold air coming into Russia. It's just for reference, it is colder even than the air that we've got compared to average coming into the western United States and the plains soon. Other points to take on here. Look how hot things are going to be compared to average, up to 15 degrees warmer than normal in parts of Brazil with some of the clearing out of the monsoon. And speaking of that, let's go have a look at global precipitation as well. So quite dry here, but very heavy rains continue into parts of southern Brazil where we've already seen some flooding. Needed rains in parts of New South Wales and Queensland as well. Very wet throughout Indonesia. Still more flooding rains down here south of the Yangtze. And it's been quite wet in the Middle East. And take a look at what's going on across Europe and Russia as well. Now, speaking of the Middle East, I went and pulled up an NDVI map of the Middle East. And right now, in these countries highlighted here, Pakistan, Afghanistan, this would be Iran, and here would be Saudi Arabia. Highest NDVI in the last 20 years. And it was also pretty high last year, but that rain comes through and you get some pretty massive desert blooms. I haven't seen any pictures, but I'm just imagining. Brazil. Now, this is interesting. Whoops. Yeah, there we go. All the way over to May. Hang on a second here. What in the world? Yeah, the timelines are different. By the way, just to make a point, NDVI values in the desert, high are 0.1. NDVI values in a rainforest, high is like 0.7. So it's just a difference here. But much of Brazil's NDVI is above average. And I'm going to reset this page very quickly because I would like to go back and change this to admin level 1 and pick out a few states like Mato Grosso do Sul. Let's go to Sao Paulo. In fact, let's grab all of the Brazilian states that are putting in a lot of this safrinha crop. I think that's a pretty good smattering. And this is what's interesting. Based on late April NDVI values, we're high. Now, the range is small, but we're high. We know there has been stress in certain areas. We know that we've had a lot of flooding here. And I don't think the satellite estimates on rainfall do this justice for some of the local heavy storms because they don't sample them constantly. But I've been receiving reports that we have had some places picking up greater than 10 inches, greater than 15 inches of rain, causing massive flooding down here in Rio Grande do Sul. And I want to be clear on something. The importance of this state to total corn and soybean production to Brazil is critical. We've gone drier in, coming up here toward Sao Paulo and Minas Gerais. I think that's how you say it. And then over toward Goiás. And so I'm stressing this particular region because we know that over the next 10 days we have heat coming back. This is fall or autumn heat. And you can look across the board here. 10-day forecast on precip, 7-day anomaly, 10-day anomaly. The pattern is still the way we've been talking about it now for about 10 days. And so not a change enough to relieve the flooding in southern Brazil or change over the drier conditions in central, southeastern, central west, those key growing areas in Brazil as the safrinha crop tries to finish. So we watch all these things and we're going to wait and see how the discussion unfolds going forward. But that's my latest. I hope you all have a good rest of your day and we'll talk soon. Thanks.